All right, in this video, we are going to apply those patterns that you noticed to actually solve problems involving 30, 60, 90 triangles. So it's important that we understand the difference between the short leg and the long leg. Your short leg is always going to be across from the 30-degree angle. So in this case, my short leg is side W, whereas your longer leg is always going to be across from the 60-degree angle. And you should be able to, when you look at the triangle, you should be able to tell which one's the longer leg, which one's the shorter leg. You can use your visual cues to determine that, but if you forget, you can always rely on where the angles are in conjunction to the legs. So my longer leg is side I, and then my hypotenuse, which is always across from the right angle, that is going to be side L. So we learned in our exploration that if we know the short leg, we can find the longer leg and the hypotenuse. So what we're going to do is we're going to let the short leg be defined as x, and our longer leg is found by taking the short leg times square root 3, so x times root 3. And then our hypotenuse is found by doubling the short leg, so our hypotenuse is considered 2x. So let's look at some examples that follow that pattern really nicely, and then we're going to look at some that require a little bit of algebraic manipulation. So on letter A, I can see that I have my short side. Well, my short side, actually I'm going to not call it short side, I'm going to call it short leg. My short leg is equivalent to x. So that means to find the hypotenuse, I have to double x, so my hypotenuse is 10. And then my longer leg is the short leg times root 3. So 5 times root 3. In part B, I was given the hypotenuse, and I know the hypotenuse is equal to twice the short side. So there's my equation. And if I think about how do I solve this equation for x, I would divide by 2. And I get x equals 4. So that means my short side is 4. So then my longer leg has to be the short leg, which is 4, times root 3. Now, do I expect you guys to set up and solve an equation, as simple as this one? No, you can do it mentally in your head, and that's fine. All right, in letter C, I was given the longer leg, and I know the longer leg is equal to the short leg times root 3. So that means since this does have the root 3, that number in front is in fact my short leg. And then I know the hypotenuse is going to be double the short leg, so my hypotenuse is 22. Now, I could technically solve this equation for x. If I want to solve the equation for x, I'd have to divide both sides by square root of 3. And when I do that, I can see the square root of 3's, they divide to 1, leaving behind x equals 11, which x equals 11 is my short leg. So let's look at a couple more. Our next ones are still going to be kind of that nice, easy pattern. So I want you to pause the video, and I want you to try D, E, and F on your own. I want you to hopefully take a minute. When you finish, unpause the video and see how you did. All right, so in letter D, you are given the hypotenuse, and we know the hypotenuse is equal to 2x. So if I divide both sides by 2, I get that my short side is equal to 5, which means the longer leg is 5 root 3. In letter E, you were given the short leg, which the short leg is just equal to x. So then that means that the longer leg is going to be 13 root 3, and the hypotenuse is going to be double the short leg, so the hypotenuse is 26. And in letter F, you were given the longer leg, and we know that the longer leg is equal to x times square root of 3. And because that longer leg has the root 3 with it, then that means the number in front, this 14, that is my short side or my short leg. So I know the short leg is 14, and the hypotenuse is double that. So the hypotenuse has to be 28. So there are 6 problems that you can reference where that pattern works out really nicely. And so let's go to some problems where we are going to have to do a little bit of algebraic manipulation to find our missing sides. All right, so in letter G, I can see that I'm given the longer leg. And I know that the longer leg is equal to x times the square root of 3. So since that longer leg doesn't have that root 3 in it, I can't just say, oh, my short side is 15, like, because then it would match the longer leg. So I need to actually solve this equation for x. And when I solve for x, that's going to give me my short side. So I'm going to divide by the square root of 3. And that leaves me with 15 divided by square root 3. And from 45, 45, 90, you should remember that we're not allowed to have a square root in the denominator. So I have to multiply the numerator and denominator by square root 3. That's the rationalizing piece. And when I do that, I get 15 times the square root of 3 all over, it would be the square root of 9, because square root 3 times square root 3 is the square root of 9, but I know the square root of 9 is just 3. And then if I analyze the coefficients, I can see that 3 goes into 15 5 times, so this simplifies to 5 root 3. So this means that my shorter side is now 5 root 3. And that should kind of make sense to you guys, like why the short leg now has the root 3 in it, because it's really similar to the 45, 45, 90. Like when we saw with the 45, 45, 90, if the hypotenuse was a whole number, then that meant the leg ended up with the root 2. So if I see that my longer leg is a whole number, then I know my short side is going to have the root 3 in it. Now, so the question is, how do I, knowing that the short side is 5 root 3, how do I get the hypotenuse? Well, remember the hypotenuse is double the short side. So I'm not going to double the radical. I'm going to just double the coefficient. And so when I double 5, or take 5 times 2, this tells me my hypotenuse is going to be 10 root 3. Now, in letter H, once again, I gave you the longer leg, okay? And we know that the longer leg is equal to x times the square root of 3. And it looks very similar to letter G, except that the longer leg is actually radical, or square root 15, versus just a plain old 15. So if I solve this equation, just like in this previous example, I have to divide by the square root of 3. And I get x equals square root 15 divided by square root of 3. And you should remember in class that if both numbers are radicals, then we can just divide the numbers if they divide evenly. And so if 3 goes into 15 5 times, so this really simplifies to just square root of 5. So my shorter side is square root of 5, which means I have to double that to get the hypotenuse. And so you might be wondering, like, well, how do I double that? Think about what the coefficient in front of the 5 is. The coefficient in front of the 5 is technically an imaginary 1. And so when we talk about doubling the short side to get the hypotenuse, if there's a radical, we only double the coefficient. So if I double 1, that means the hypotenuse is 2 root 5. All right, and let's take a look at this last problem. This last problem says that the perimeter of an equilateral triangle is 36 inches. So I'm going to draw myself a picture of an equilateral triangle. And we addressed at the beginning in the previous video that an equilateral triangle means all of the sides are equal, or they're congruent. And so if my perimeter equals 36 inches, and I have 3 congruent sides, I need to divide this by 3, and this tells me that each side is equal to 12 inches. So this side is 12, this side is 12, and this side is 12. And the question says, find the length of the altitude. The altitude is really just the height of the triangle. So if I draw the height in, just like we did in our exploration, I know that it's cutting the triangle completely in half. So instead of thinking the bottom as 12, I can think of the bottom as 6 and 6. And so because this is an equilateral triangle, I know this angle is 60. Drawing the height in produces a 90-degree angle, which means this angle sitting here at the top is 30 degrees. So this follows our 30, 60, 90 pattern. And so when I look at the bottom, this is my short leg. this is the hypotenuse. So the question is, what is the height? What is the longer leg? Well, this one follows the pattern really nicely. I can see if my short side is 6, that the 6 was doubled to get the hypotenuse. So that means that the height is going to be the short side, or the short leg, times root 3. So the height is 6 square root 3, and that would be inches.